Hello, fourth grade. Welcome to 5.9, Choose a Strategy to Divide. So far in our lessons, we've been talking about how there's more than one way to divide, whether you're using partial quotients, area models, if you're using long division, using the standard algorithm, then that is another strategy as well. Or even if you want to use estimating, that works as well. But that only gets you to a number close to your actual quotient. But the question is, what do you do or how do you choose between which strategy you want to divide with? So in this lesson, we're going to follow a series of steps that breaks the division into simpler calculations. So in our math tip for this lesson, you can use reasoning and estimating to see if the answers are reasonable. Show your work, of course.
Choose a strategy to solve each problem. Explain your solutions. Problem 1. There are 135 fourth grade students. Each lunch table seats 6 students. How many tables are needed to seat all of the fourth graders? Problem 2. A high school football stadium has 5 sections. Each section seats the same number of people. A total of 1,950 people can be seated in the stadium. How many people can sit in each section?
So in the first one, we can go ahead and annotate our question, 135, and we know that there's 6 students per table. We need to figure out how many tables are needed for all of the fourth graders. So we're starting from 135, and we're dividing it by 6. And so in long division, that would look like this, 6 and 135. Now, of course, if you want to look at the partial quotients, then that means that we're not going to look at the first digit if it's smaller than our divisor. So let's look at the second one. So in this case, we have 13 or 130. 6 can go into 13 2 times. And so now, or 20 if you want to do it like that, then that means that we have 120 right here on the bottom. And we have 15 left over. 6 can go into 15, again, 2 times. Oh, I ran out of space there. So I'm just going to put plus 2 right there. And so now I have 12, and I have 3 remaining. So that means that I have 22 with a remainder of 3. So that means that how many tables will they need? They'll need at least 22, probably 23 tables for all of them to sit. For problem 2, we know there's 5 sections, so that means it's being split apart. 1,950 people. How many people can sit in each section? So 1,950 divided by 5. 1950. So 5 can go into 19. How many times? Well, since I know 5 times 4 is 20, I know that 5 times 3 will get me 15. And I can go ahead and put, oopsie, I can get my 4 right there on the bottom, 485. And so now I know that I started from 300 plus my next partial quotient. 5 times what equals 45? 5 times 9 equals 45. I get 0 left over. So in this case, 300 plus 90, and I get 390 people per section. Let's go ahead and begin page 202 with our video lesson.
How do you choose a strategy to divide? The table shows the number of hot dogs sold on game days last week. There are 8 hot dogs in a package. How many packages of hot dogs were used on Saturday? Divide 834 by 8 to find the number of packages used on Saturday. Think about which strategy you can use to solve the problem. Think, I can use partial quotients. There are 108s in 834. There are 4 8s in 34. 834 divided by 8 equals 104, remainder 2. How many packages of hot dogs were used on Saturday?
Select your answer.
They used 104 full packages plus 1 more for the 2 remaining hot dogs. There were 105 packages of hot dogs used on Saturday. On Sunday, the 3 food stands each sold the same number of hot dogs. How many hot dogs were sold at each stand? You can use the distributive property to divide 216 by 3. Think, I can break 216 apart and divide with mental math. 216 equals 210 plus 6. Divide each part by 3 and simplify. 72 hot dogs were sold at each stand. How do you decide which is the best method to use when solving division problems?
So when we think about which method we can use, you might remember in our previous lesson we talked about place value blocks, and that's really for equations where we have smaller dividends. You can also use another strategy like partial quotients, and we used it in our previous example, and area models. So that's another strategy you could use as well, and that works with just about everything. The distributive property also works well when you know the numbers that are easily to mentally divide. And so it just depends on the equation. Let's go ahead and begin our guided independent practice. Here's another example for you to look at. This one doesn't have a remainder. I'm using the place value blocks. We're on 5.9. Choose a strategy to divide. I've learned a few ways to find quotients like partial quotients, breaking apart dividends into place value, and the standard for long division. But sometimes one strategy can be more helpful depending on what the problem is asking. For example, 8 hot dogs were sold in a pack, and on Saturday, 834 hot dogs were sold. How many packs were used? And so here we did 834 divided by 8. And so since we know that 8 can go into 800 100 times, we did 100 right there. And then we removed 800, and then we had 34 left over. Then we had 8 times 4, which gave us 32. And so now, when we subtracted it, we had 34 take away 32, which gave us 2 as a remainder. So now we have 104 with a remainder of 2. Since there is a remainder, I know a new pack was open, so there were 105 packages in all. I used partial quotients because I didn't know the whole quotient yet. If I know the dividend is easy to divide with mental math, I can use the distributive property. For example, here, 216 divided by 3 is the same thing as saying 210 plus 6 divided by 3 equals 70 plus 2, because 210 divided by 3 equals 70, 6 divided by 3 equals 2, and so our total quotient is 72. How do I know which strategy to use? Well, the smaller dividends are easier to divide with place value blocks or drawings. Partial quotients can be used for long division and area models. I can use the distributive property for mental math equations. And so now for number 1, it says, explain how place value blocks can help you with division. And for numbers 2 through 3, we have 7 divided by 659, or 659 divided by 7. Let's go ahead and check our math textbook and do it here instead. All right, and I'm going to zoom in so that way it's a little bit easier. Actually, let me get my handy dandy pencil. There we go. Okay, Vicky's estimated quotient was 80. The actual quotient she calculated was 48. Is her actual quotient reasonable? So 48, is that close to 80? Definitely not. So we can go ahead and answer no. The numbers are not close, so her answer is not reasonable. Numbers are not close. So her answer isn't reasonable. For numbers 2 through 3, divide. So now, whenever you're looking at an equation, remember, you can break it apart into its place value. So here I have 2,871 divided by 9. I'm going to go ahead and just look at these first two digits and think of it like 28. So 9 can go into 28. Well, I know 9 times 3 will give me 27. And so when I subtract it, I will have 171 left over. And so again, looking at the first two digits, because I know 9 can't be divided, 1 can't divide 9 equal parts. So now thinking about 17, 9 times 2 equals 18. So that means that I'm going to go ahead and use my partial quotients. 9 times 1 group of 10. In this case, I'm going to go ahead and subtract it by 90. And so now I can go ahead and subtract, get 1 left over. 17 take away 9, that gives me 81. And so, oopsie, or 9 times 9, that equals 81. And when I subtract it, I get 0. So now my whole quotient is 319 with no remainders. For number 4, looking at these numbers, I can see that they're easy to mentally divide. So I can go ahead and think of it like this. 460 if you want, plus 8. And so that's one strategy you could do. If you want to do it directly, maybe you do it like this. 400 plus 60 plus 8. And so now, looking at the long division version of it, 4 can go into 400 100 times. And so I'll have 400 down here. I'll have 68 left over. 4 can go into 68 only one time. And so I'll have 40. And so 8 down here, 6 take away 4, that's 28. And then 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, and 4 times 7 is 28. And there are no remainders. So now my whole quotient is 117. So if you use this strategy or if you use this one, your answer should still be 117. That is the end of this lesson. So please make sure to write your answers neatly for your independent practice and your problem solving on the back. Please make sure to check your work and turn it in on Google Classroom as soon as you're done. All right, I'll see you in our next lesson.